Hi friends, welcome back to the course. So, uh, apologies first of all because there were a few corrections in the last lecture. So, in the last lecture, we talked about logarithmic decrement, which is defined as natural logarithm of x1 divided by x2, where this is the plot you can see here. This is the plot. X1 is this displacement and x2 is this displacement. I already talked about this corresponds to an undamped case, and we talked about the amplitude decreases exponentially, but there is a time period, or there is a periodicity associated with this particular curve, and all those stuff we talked about. So now coming back to the place where I made the mistake, it is here. So when I talked to you about how in practice actually how we compute this delta logarithmic decrement, I told you it is not that easy to measure the amplitudes during a very small time interval. Let's say this will be a very small interval, so almost in practice we won't be able to measure this kind of a very small or a very short duration of time. So mostly what we do is we will measure the first amplitude, and then we will wait for, like, let's say n cycles, and then we will measure xn. So if you know x1 and xn, we need to compute your delta. So we will go about doing that like this. We have, let's say you have x1 and xn, it can be written as x1 divided by x2, then like this. I think the terms just the terms in the denominator and the numerator got interchanged in the previous lecture, I think so. So that was the error. Then each of these terms from this formula is e to the power delta, simple algebra. Then now you have this is the formula connecting your logarithmic decrement and the difference in amplitude, or the ratio of amplitudes. That's it. So once again, apologies for the small error which I made, and that's it. One more thing, in the last lecture I also talked about a time period of this curve. So you have to understand that this term was composed of two terms. This whole term, then sine omega dt plus phi. So whenever I was talking about the period, I was referring to the period of this particular term. If I call this is the first term and this is the second term, then whenever I talked about the time period, I told you there is a damped time period Td, which is given by 2 pi zeta omega n root of 1 minus zeta square. I referred to the time period of this second term. Obviously an exponential function, this term cannot have a time period because it keeps decreasing all the time. So I didn't explicitly explain this thing in the earlier lecture. So whenever I referred to time period, I was referring to the time period of this particular term. Okay, thanks.